Everyone, so today I'll be walking you through the implementation of linear and logistic regression using Python, along with their evaluation metrics. These two models are among the most widely used tools in machine learning, so understanding how to build and evaluate them is very important. So let's start with a question. So let's look at the assignment overview. In this assignment question, we focused on linear regression, which predicts continuous values, logistic regression, which predicts classes using probabilities, and finally evaluating both models using the right metrics. We implemented everything Python and scikit-learn library. So let's go towards the linear regression fundamentals. Linear regression tries to fit the best possible straight line through the data. It's used when your output variable is continuous, things like price, ratings, or sales numbers. It assumes a linear relationship between input features and the output. So linear regression code implementation. First, we'll discuss about evaluation metrics. So linear regression evaluation metrics. To judge how well our regression model performs, we use two main metrics: RMSE, root mean squared error. It tells us how far our predictions are from the actual values. R2 R2 square score. This tells us how much of the variance in the data the model explains. A value closer to 1 means a better fit. So let's discuss about the code implementation now. So important, here's the basic workflow we followed. Import libraries and load the data set. We separated features X and target variable Y. Split the data set into training and test sets. Train the model using linear regression function dot fit function, and make predictions on test data. Now calculate RMSE and R square using scikit-learn functions. This gives us a clear idea of how well the model is performing. Now let's talk about the logistic regression fundamentals. Logistic regression may have regression in its name, but it's used for classification. It's worked by taking a weighted sum of inputs, passing it through the sigmoid function, producing a probability between 0 and 1. If the probability is above zero point 0.5 and we classify it as class 1, otherwise it is class 0. Logistic regression evaluation metrics. For logistic regression, we can't evaluate using RMSE or R square. Instead, we use classification metrics like accuracy, precision, recall, F1 score, specificity, and confusion metrics. Together, these metrics show how well the model predicts both positive and negative classes. Now let's talk about the code implementation. So the implementation steps are similar to linear regression. Load and prepare data, initialize logistic regression, train the model using fit function, predict classes using predict, compute all metrics, accuracy, precision, recall, F1 and specificity, generate a confusion matrix for deeper analysis. This gives a complete evaluation of the model's performance. Now, understanding the confusion matrix. A confusion matrix is a simple 2 by 2 cross 2 table that shows true positive TP, true negatives TN, false positives FP, false negatives FN. From these four values, we calculate all other metrics like precision, recall, and specificity. So, to give the metric summary, we can say that for linear regression, RMSE measures average error, R2 R square score measures how much variance the model explains, and for logistic regression, it's accuracy, precision, recall, F1 score, and specificity. Each of these tells us something unique about model reliability. Let's talk about the key takeaways now. So to wrap it up, use linear regression for continuous predictions, use logistic regression for classification, always choose evaluation metrics based on type of model, follow a clean workflow, load, split, train, predict, evaluate, and finally never rely on just one metric. Multiple metrics give the full picture. So I hope this made the implementation and evaluation of both regression techniques clear and easy to understand for both linear regression and logistic regression. I hope you like my video. Thanks for watching.